Hello everyone. In this lecture, we will see some numericals about the chemical kinetics. So, if you look here, the first screen, that is the first numerical of this lecture, it says that the first order reaction A gives B has K is equal to 5.67 per second if A0, that is concentration of A at 0, that is equal to 0.500 molar. How long will it take for concentration of A is equal to 0.124 molar? So when you read this numerical, first of all we have to see what is given. So we have given that the rate constant K. We have also given the initial concentration, and we have asked how long, that means time is asked for given concentration, that is A is equal to 0.124 molar. So this is the given data. Now we have to solve this numerical. So it is very simple. It is not a hard numerical. It is very easy numerical. When we got the given data, then it is very easy to solve this numerical. So we will see the next slide. So now see here what we have given. I will show you. Given that K is equal to 5.67 per second, that is the rate constant is given, initial concentration is given, time is asked, but when concentration of A will be 0.124. So value of initial concentration is nothing but A, that is equal to 0.500 molar. So concentration of A is equivalent to A minus X after time T. When particular time period extends out, that time we say that after time t the concentration remain, so that is nothing but A minus X. So we have studied this first order kinetics equation. We have also derived the equation, so from which we have got the last equation, K is equal to 2.303 by T log to the base 10 A upon A minus X. So A is the initial concentration, A minus X is the concentration remain after particular time period, that is T. So A minus X we can substitute here 0.124 molar. So K is equal to 2.303 by T log to the base 10 A upon A minus X. This is the first order kinetics equation which we have to use to solve this numerical. So just put up the values. For T we can write just rearranging T in place of K and K in place of T. So equation become 2.303 by K log to the base 10 A upon A minus X. So when we substitute the values, you can see here 2.303 by value of K, that is 5.67, value of initial concentration A 0.500. So A minus X, that is the concentration remain after time T. So that we have to put up 0.124 and we have to determine the time and just calculate this dividation. This dividation, take the log and you will get the time 0.2458 seconds. So that will be the answer for time for this numerical. Now we will see the next one. Now if you look in the screen, a reaction is a first order in A if the rate constant of reaction is 3.45 into 10 raised to minus 3. So what is given? This is the first order reaction. Rate constant is given, that is 3.45 into 10 raised to minus 3. And what is the half life? That is we have to determine. So half life, first order reaction, half life equation we know, that is the relationship between half life period and first order reaction rate constant. So this is given that K 3.45 into 10 raised to minus 3, T half we have to determine. Simple equation we have to use for first order kinetics, K is equal to 0.693 by T half. So T half is equal to 0.693 by K. So K is given, that is we have substituted here and calculate. So it is T half is equal to 0.200 into 10 raised to 3, that is nothing but 200. So always write the unit for half life period because it is also important. So T half is equal to 200 seconds. So in this way we can calculate half life period if rate constant of first order reaction is given, then by using simple this formula. So now we will see the next numerical. The half life of a first order reaction is 0.950 second. What is the rate constant? Similar to the before numerical, half life is given, and now there is a asked that is rate constant. So again we can use a simple formula. Given that we have 0.1950 k, we have to determine for first order reaction. Formula is very simple. K is equal to 0.693 by T half. Put up the values of half life period which we have given and just take the dividation. You will get the answer 0.7294 per second. Remember the unit for rate constant is per second because this is the first order reaction kinetics. So in this way we can solve this one. Now the last numerical of this lecture we will see in the next one. What percentage of material will persist after 80 minutes if its half life is 20 minutes? Now see what we have asked, what percentage of material, that means we have to determine the concentration remain after particular time. So time is given, that is 80 minutes. That means after 80 minutes what will be the percentage of reactant we have asked. What is given? Half life period is given. So write in the answer that is given data. What is T is equal to 80 minutes, half life period is 20 minutes. So with the help of these two given data we can calculate rate constant, and after calculating rate constant we have to determine the concentration. So we must know the rate constant and time. Time is given. We don't know the rate constant which we have determined with the help of this half life period. So for of first of all we have to determine the rate constant. So K is equal to 0.693 by T half. T half is given. With the help of this we can determine rate constant which is required for the calculation of concentration remain after a particular time, that is 80 minutes. So K we have determined, put up the value of K, and T we know 80 minutes. So now we can easily calculate A minus X. Now in this case I have written here when the percentage, the A is always 100. When the percentage is asked for the concentration, when percentage is asked, that time initial concentration of the reactant is always considered to be the 100. So it is 100 upon A minus X. We have to determine this factor A minus X. So log to the base 10, 100 upon A minus X is equal to this 80 in dividation goes to the left hand side into multiplication. So 0.03465 into 80 upon this will go into the dividation 2.303, and after calculation you will get the value log 100 upon A minus X is equal to 1.2036. Now when this log will be removed, factor remains 100 upon A minus X. It goes to the right hand side and becomes anti-log. So anti-log of 1.2036. When above in front of point, value should be considered for consideration of anti-log. So 2036, take the anti-log, it is 1598, adjust to the characteristic 1, so it is 15.98. So 100 upon A minus X is equal to 15.98. So A minus X is equal to 100 upon 15.98, and the answer is 6.2578. So the percentage is A minus X is equal to 6.2578. So that is the answer for this numerical. So thanks for cooperating. Study each and every numerical. See the answers. If you have any queries, any problem, you may communicate. Thank you so much.